Trig Tools for right-angled triangles. This is page 16 of the maths tables. We have a right-angled triangle here. We know it's a right angle because we have this little square in this corner that indicates it's a right angle. Side C is the hypotenuse. The hypotenuse is always opposite the right angle. Side little a is opposite the angle capital A. And side little b is adjacent to the angle capital A. The definition of sine, cosine and tan. The sine of the angle A is equal to the opposite over the hypotenuse. Sine of the angle A is equal to A divided by C, the opposite divided by the hypotenuse. The cosine or cos of A is equal to the adjacent divided by the hypotenuse. The adjacent divided by the hypotenuse. The tan or tangent of the angle capital A is equal to the opposite divided by the adjacent. Tan of the angle A is equal to the opposite divided by the adjacent. This only applies to right-angled triangles. Pythagoras' theorem. Pythagoras' theorem tells us that the square of the hypotenuse is equal to the sum of the square of the other two sides. So the square of C is equal to the square of A plus the square of B. The square of C is equal to the square of A plus the square of B. I have a cartoon here to illustrate this. This is a right-angled triangle as indicated by the little box here in the corner. The sides are 3, 4 and 5. If I put a square around this, so this square is side 5, there's 25 squares in here, 5 multiplied by 5, so the square of 5 is 25. This side is 3. If I build a square around that, the square has got 9 little squares in it, 3 multiplied by 3. This side is of length 4. If I build a square around that, there's 4 multiplied by 4, so there's 16 little squares in this. Pythagoras' theorem tells us that the square of the hypotenuse, which is 5 squared, equals the sum of the square of the other two sides. This side is 3, 3 squared. This side is 4, 4 squared. Square these up, we have 25 equals 9 plus 16. And in fact 9 plus 16 is equal to 25. So that illustrates the Pythagoras' theorem for the right-angled triangle 3, 4, 5. There's another tool that's useful for triangles, and that concerns the sum of all the angles, all the interior angles. This is a right angle here. This angle is B and this angle is A. What it tells us is that the sum of all the angles must add up to 180 degrees. So we have A plus B plus the right angle, which is 90 degrees, must equal to 180 degrees. This is true for all triangles. If they do not add up to 180 degrees, then you've either made an error or it is not, in fact, a triangle. It is true for all triangles, even triangles that are not right-angle triangles. If we take this triangle here as X, Y, and Z, of angles X, Y, and Z, if I add them up, X plus Y plus Z must equal to 180 degrees. Inverse. Inverse is rather like an undo. If we have x squared and we take the square root of it, we're undoing the square. So the square root of x squared is equal to x. An example might be if we are told that x squared is equal to 16.81. I want to undo or invert this square here. So I take the square root of x squared, and because it's an equals, I have to do the same on each side. I have to take the square root of 16.81 0.81. So the square root undoes the square, and on this side then we're left with x equals the square root of 16.81. Bit of calculator work then tells us that x equals to 4.1. So the square root of 16.81 is 4.1. If we are given the square root of x, we can undo that or get rid of the square root by squaring it. So the square of the square root of x equals x. An example would be if we are told that the square root of x equals 3.8 and we want to find what x is, we want to undo this square root here. So to undo a square root, we take a square. So the square root of x, undo it by taking the square. Then we must take the square of the other side because it's an equation. So 3.8 squared. This square undoes the square root, so we're left with x on this side is equal to 3.8 squared. A bit of calculator work then tells us that x is equal to 14.44. We have inverses for the sine, cosine and tangent. If I'm told that the sine of the angle A equals x, then the inverse sine, and the notation for the inverse sine is sine to the power of -1 of sine of A equals the inverse sine of x. Because it's an equation, we must do the same thing on each side. So the inverse sine cancels out the sine, and we're left with A on this side equals the inverse sine of x. An example would be if we are told that the sine of the angle A equals 0.5, then if I take the inverse sine of each side, which the inverse sine of sine will cancel, I'm left with A equals the inverse sine of 0.5. A bit of calculator work will tell me that A equals 30 degrees. And on the calculator, here is the sine button, and to access the inverse sine, which we see up here in yellow, we have to press the second function button and then the sine button. So we are told that sine of A is equal to 0.5. We want to get the inverse sine of 0.5. Second function, sine, you can see on the display, this indicates the sine, the inverse sine of 0.5 equals 30. We have 30 there. That is the inverse of the sine. Cosine, inverse of cosine. If we are told that the cosine of the angle A equals x, and we want to find out what x is, we can take the inverse cosine of each side. So it's cosine inverse of cosine A equals, we must do it on the same of each side, cosine inverse of x. This inverse undoes the cosine here, so we're just left with A equals inverse cosine of x. A concrete example would be if we are told that the cosine of the angle A equals 0.8480. If I take the inverse cosine of each side, it undoes the cosine here. I'm left with A on its own. is equal to the inverse cosine of 0.8480. And a bit of calculator work. Here's the cosine button. The inverse cosine is indicated in yellow. So I press the second function, cosine of 0.8480 equals 32 degrees. If we round that up, equals 32 degrees. Inverse tan. If we are told that tan of the angle A equals x, then the undo or the inverse tan of the tan A equals the inverse tan of x. The undo here, the inverse tan of tan just leaves us with A equals the inverse tan of x. A concrete example would be if we're told the tan of the angle A equals 1.7321. Thinking the inverse tan of each side of this, the inverse tan of A just leaves A. A equals the inverse tan of 1.7321. Doing a bit of calculator work, we get A equals to 60 degrees. And let's look how we got that on the calculator. Here is the tan button. In yellow above it is the inverse tan. You get at that by pressing the second function, this yellow button. So we've inverse tan of 1.7321 equals 60 degrees. Now we can look at what happens if we take the sine of 30 degrees. If I take the sine of 30 degrees, it gives me 0.5 on the calculator. That shows me that the sine of 30 is 0.5. The inverse sine of the sine gives me 30 degrees. If we take the cosine of 32 degrees, we get back to 0.8480 as per the concrete example. If I take the tangent of 60 degrees, I get 1.7321.